Job interview, software developer, the portfolio spotlight.
Hi, Elena. Welcome to the technical round of our interview process. How are you doing today?
Hi, Michael. I'm doing great, thank you. I'm really excited to be here and discuss how I can contribute to the team.
Awesome. Let's dive right in. I was looking at your portfolio, and your work on the scalability project at your previous company caught my eye. Could you tell me more about it?
Of course. We had to redesign our core e-commerce platform because we were facing massive performance issues during flash sales.
The classic high-traffic spike problem. What was the exact bottleneck you discovered?
Well, the primary issue was database locking. Our relational database couldn't handle the sudden rush of concurrent write operations.
I see. When everyone tried to buy at the same time, the database got overwhelmed. How did you approach this?
First, we decided to decouple the checkout process. We didn't want the user to wait synchronously for the database write to finish.
Smart move. So you introduced an asynchronous pattern. What technology did you choose for that?
We implemented RabbitMQ as our message broker. It allowed us to queue the checkout requests and process them at a steady rate.
That works well for ingestion. But how did you handle the inventory updates? Users need to know instantly if an item is sold out.
That was a major challenge. To solve that, we kept the inventory count in Redis instead of querying the main database.
Redis is great for fast in-memory operations. How did you ensure data consistency between Redis and your primary database? We used an eventual consistency model. Redis acted as the source of truth for the active session, and a background worker synchronized it back to PostgreSQL. Interesting. What happened if a network partition occurred and Redis went down?
We set up Redis Sentinel for high availability with automatic failover. We also had a fallback mechanism that routed traffic directly to a read replica database if Redis was unresponsive.
That shows some solid planning for failure. Now let's talk about API design. How did you structure the endpoints for this service?
We designed a RESTful API with strict versioning. For example, we used v1char checkout to avoid breaking changes for existing client apps.
And how did you secure these endpoints against automated bots trying to hoard items?
We implemented rate limiting at the API gateway level using the token bucket algorithm.
What was the limit you set?
We limited it to 60 requests per minute per IP address, which was more than enough for a human user, but blocked most basic script attacks.
Excellent. Let's talk about the database again. PostgreSQL is relational. Did you consider a NoSQL database for the product catalog?
We actually did. We debated switching to MongoDB for the catalog because product attributes can be very dynamic.
What made you stick with a relational database then?
ACID compliance was critical for transactions. We realized we could use PostgreSQL's JSON-B data type for dynamic attributes without losing relational integrity.
That's a very practical compromise. It saves you from managing two different database technologies if you don't have to.
Exactly. We wanted to keep our architecture as simple as possible while still meeting our performance goals.
How did you monitor the performance of this system after deployment?
We set up Prometheus for metrics collection and Grafana for visualization. We also integrated PagerDuty for real-time alerting.
What metrics did you monitor most closely?
API latency, CPU utilization of the database, queue depth in RabbitMQ, and of course, the 5x error rate.
What was your target for API latency?
Our goal was a P99 latency of under 200 milliseconds, and we managed to maintain that even during peak traffic.
That is impressive. How big was the team you worked with on this migration?
It was a cross-functional team of 5, 3 back-end developers, 1 DevOps engineer, and 1 QA automation engineer.
And what was your specific role in that team?
I was the lead developer for the checkout microservice. I designed the database schema, wrote the queue consumers, and handled the integration tests.
How did you ensure the system was thoroughly tested before going live?
We did extensive load testing using Locust. We simulated up to 10 times our expected peak traffic to see where the system would break.
And where did it break during the test?
Initially, the connection pool to PostgreSQL exhausted quickly. We had to optimize our database connection settings and implement PG Bouncer.
PG Bouncer is a lifesaver for connection pooling in Postgres. Good catch.
Yes, it reduced our database overhead significantly.
If you had to build this system all over again today, what is one thing you would do differently?
I would probably look into using gRPC instead of REST for internal communication between our microservices to reduce payload size and latency.
That makes sense, especially for high-frequency internal calls. Well, Elena, I'm highly impressed by your systematic approach to system design.
Thank you, Michael. I really enjoy solving those kinds of complex architectural puzzles.
It definitely shows. Do you have any questions for me about our tech stack or our engineering culture?
Yes, actually. I know your team is migrating to Kubernetes. How are you currently managing configuration and secrets across your environments?
That is a very timely question. We are actually in the middle of adopting HashiCorp Vault. It's been an interesting transition.
See you in the next English conversation session by Wisdom Studio 8.